Alright, so in creating lesson 6, I realized that there was some stuff from the very beginning that was introduced in the lesson that they automatically assume that you know this terminology, and I realized that you probably don't. And it's the word mathematical terms. So, underneath your heading for lesson 6, write this question: what are terms? It's not going to be a whole lot of writing, believe me, but I teach you to definitely write it down so you have a basis of reference. So let me start off by giving you the definition. Don't write anything down yet. Just let me read it out loud to you. I'll then allow you to write it down and we'll talk about it. In algebra, a term is either a single number or a variable, or numbers and variables multiplied together, and then terms are separated by plus or minus signs. So write that down and then we'll start to discuss it. While you're finished, you can copy that down and read out loud. In algebra, which is what we're currently doing, a term is either a single number or a variable, or numbers and variables multiplied together, and then those terms can be separated by a plus or a minus. So let me give you a break. Before I reveal this, perhaps a couple of them verbally. The number 5 is a term. Its definition: either a single number or a variable. Is 5 a single number? Yes. So it's a term. And by the way, when I say single number, I don't mean a single digit number, because 182 is still a term. Any number. Positive ordinate. Negative 38 is a term. Yes. Negative 12.5 is a term. Yes. And it doesn't have to be just integers either. It can be rational numbers. What about 1/4? Yes. It can also include variables. What about x? Yes. What about y? Yes. What about z? Yes. Q. Alright, so you got it in your head. Let's just formalize it so you haven't had to look back on it. X is the term. Yes. So write down the letter x next to it, or make a line and say yes. Now, spell out yes or no. Because if you hit y or n, it looks like a variable. Right? So we're clear. When you look back in a week or so, you don't want to see the letter y next to an x and not realize that y means yes. So spell it out.
A single number doesn't mean like, can you have like 25?
Yes, it could be a million. Okay? And what I mean by a single number, it means it's really any number by itself is still a term. What about 5?
Yes.
What about 51? You know it's not there.
Yes.
Good. No, it's okay. What about plus sign?
Yes. Oh, wait.
No, because terms are separated by plus or minus. Those will separate the terms, but the signs themselves are not. I think this is the last one. What about 3y?
Yes.
Why, like, how come? Why? How come we're considering that a term? But what in the definition tells us that it is?
Numbers and variables.
Right, so get this into your head that 3y means 3 times y. So the answer is yes. Yeah, n squared.
Yes.
How many say yes? How many say no? What two variables multiplied together make n squared? Sure, so n times n, okay? But no, what it is still n times n. So you can still have two variables multiplied together. It's still a term. Okay? So numbers and variables multiplied together would also include. What about x, y? Is that a term? Okay? Now, if I were to separate this out, now you have two terms, right? You have the x and the together, it's still considered one term. And now that's going to kind of lead into the whole gist of what lesson 6 is about. It's called combining like terms. Combining terms that are the same. We'll get to it. This is a yes. And I think I got one more half page. Okay, you ready? Right down to the flip. Okay, yes, write out this question. How many different terms are in each expression? What are they? And then we'll put it together. When I drop the sheet down, write down the expression, and then we'll do the first one together. And let me see that tool. It's not as big as the other one. 3y minus 5. Just write that expression down first. So I'll ask you, how many terms do you say? Calculation. Viv. Does everybody see that there's two terms?
Yes.
What are they, Viv? And again, spelling this out, because if I put the number 2, it's going to get kind of confusing in terms we're going to have to write out. I'm going to separate it by a comma, 3y and the number 5. Not the minus sign. Here's the next one. 3. How many turns out? 2. You want to write just the word 2, not the word terms. That's fine. What are they, Al?
12x.
Separated by a comma. Good. A little tricky, but doable. X times X. Not yet. We'll get to that. We'll get to that. Right now, as is, how many terms do you say? No. Everybody agree there's 2. Yeah, and I'm going to ask you to write out the letter X twice. So if you see them twice, you list it twice. Okay, what about this one? 7m plus 80 is 9. All right. So everybody see it? Great?
Yes.
Great. 7m is one of them, right? 8 and 9. Now let me read it out loud, kids. It's tiny. 3n plus y cubed minus 15. How many terms do you see? And I also see 3. You all see 3?
Yes.
Okay. And what are they? Good. What else? And the last one? Sounds good. I think there might be one more. Let me see. Nope, that's it. Now, you want me to give you a little sneak preview of what lesson 6 is all about? I already saw it. You started to see it, which is great. Before we do that, do you understand the idea of terms?
Yes.
This is very much missing in lesson 6. And we're going to build off of this. Go back to the third item. You take x times x and combine it.
Yes.
What would you make? What would be the combined term? X is the power of x squared. But what you just did is something called combining like terms. You took two terms that could be combined, they're the same, and combined it into one. It's now one term. X squared is one term. Do you see anywhere else where that can be done? Any of the remaining problems or expressions? And I'll give you a hint. There is one more way you can do it. Right.
Be like addition.
Tell me.
Equals 9.
What is equals 9?
Plus
What becomes the new expression when you do that?
7.
Listen. 3 terms have just been combined into 2 terms. He's right. You can see. If you add 2 numbers, you can add those together. If you have 2 variables multiplied together, you can combine those as well. Okay, that's kind of the gist of what lesson 6 is about. I'll start you off slow, and then we build on it. By the time you get to the middle of it, it starts getting complicated. But this is the building blocks of understanding terms in order for you to proceed into lesson 6. All right? Any questions on this before I ask you to physically hand out the packets? Good? All right. Everybody's got lesson 6, right? Yeah. We're actually going to go backwards before we go forwards. What I mean by that is I'm going to recap stuff you really do already know, and we'll build on that. Okay, so we talked about terms, right? Terms can be broken down into what's called a coefficient variable. We take this expression here, ax, a single term, right? How do you write this out for us? This is what I mean. We're going to go backwards before we go forward because we've done this. What is this telling us to do? How would you put it into terms? Right. Which is a good recap anyway. So one, you can get it in your head. So it's a routine. If you see a number called coefficient with a letter, it means multipliers. Alright, so here comes something new. There's new vocabulary in this lesson. So everybody say the word coefficient. Coefficient. In an algebraic expression like the one above, the number before the variable is called a coefficient. Coefficient is a constant factor in an algebraic expression. The letter after the coefficient is also a factor, but when expressed by a letter, it's called a variable. You know that. So in 8x, what's the coefficient? Variable. Let's go back before we go forwards. Okay, we good with that? Example 1 was easy, right? Example 2 is going to be no more difficult than example 1. Start you off slow, and then it's going to build, build, and build. And again, you know this already. We're getting rid of the dots. We don't like dots. Dots look like decimals. So, writing out the expressions, we want to be able to write the expressions with fewest numbers and symbols. We no longer use the x in an algebraic expression. Why don't we do that? Okay. Because it looks like variable. Very good. Alright, that's it for this page. One thing I want to, so this might have been you that mentioned this yesterday. Whenever you, I think somebody in here, but let me know. Whenever you express a number next to a variable, you always put the coefficient before the variable. Ask that yes? Right, like if you have 6 times x or 5 times y, the coefficient always goes before the variable. don't want to do this. Why? Yeah, it looks like exponents. That's part of the language of math. That exponents always go after the variable, and also it's called superscript. It goes above it and it's slightly smaller. But it's not always. If you don't write it tiny, you write it too big. You can't tell whether it's an exponent or if it's a coefficient. But if you put it always before, then we know it's a coefficient. We know it means, in this case, 5 times 5 and not y. It's just the language of math. You try to remember it, that's great. What about 6x? What's the coefficient? Variable. Yeah, you need both. Great. Now you can also do, once this out, this is a typo. We're still talking about expressions, please. Algebraic expressions can also be the multiplication of two variables without a coefficient. A times B without using the dot. How do you express that? Good. And then a quick recap question. How many terms? Hold up with your fingers, let me say. Most of you just fall into the trap. It's good. It's still one term. Yes, it is. Okay? If I expand it out and do this, now that's 2. But combining like terms can also mean that we can take A times B, and it really means as a single term, 8A. Now, if we substitute a number in for A and substitute a number in for B, let's say A is 3 and B is 2. You can't do this. It looks like this is the term 32. Once I plug in or substitute a number for the variable, I have to add back in that multiplication dot. Okay? I kind of gave a sneak preview. That's really what number 5 is asking. If I have 3 times 5, I have to include the multiplication symbol. Why? I already kind of expressed it orally, but let's recap that. Go. You got it. It looked like 35. It's confusing. Now, you guys warm. Let's open that window and we got 6 inches. Go for it. Get out the measuring stick. It's a little game we play in ELA. Are you ready to take a slowly? Before we do what we're going to do here on the bottom, look at the box and tell me how many terms you see. I don't want to identify how many you see. How many see 4? We're going to get 6, get next, get 5, get 1. Okay? What we're going to do is we're going to substitute the given numbers for the variables that they give you. So if x is 2, we put it up there for right now so you can see it, and we'll rewrite it. Y is what? Now rewrite the expression with the numbers now that have been replaced. That have replaced the variables. Should get that right. It's going to allow you to take a shortcut. They're all multiplication. So multiply them all together and what you get. Joe. Okay? 60 here. Circle it. Don't forget it. Again, a recap. How many terms did you see? Okay. Proceed. What you do, when you combine my terms, all of your coefficients the numbers, you can multiply them together. And then, whatever variables are left over, and combine those together. So, what were the coefficients for numbers in the box? Just the numbers, what were they? Go ahead. Forget about the substitution right now. Go back to the original expression. And 6 times x times 5 times y. What numbers do you say? 6 and 5, right? Multiply them together, what do you get? You get 30. X times y is... Here we go. Here comes the leap.
XY.
XY. We don't know what those values are yet. Forget about your 2, forget about your 1 for now. What I just did is took this expression 6 x times 5 times y, and I have combined it, condensed it, crunched down to make 30xy. Are you okay with that?
Yes.
The way that you listen, probably the best advice I can give you, the most important thing out of lesson 6, is when you combine like terms, and if you've done it correctly, when you go to substitute those values that I gave you, x and y back on the previous page, you should get the same answer. What was the answer from the previous page? 60. Now what we're going to do, here's my expression, my new expression, 30xy. Right? We're good? What was the value that I gave you for x on the previous page? What? What must I add between the 30 and the 2 now that I'm going to multiply? What? Make a little dot. What was the value I gave you for 1? I asked. Got it.
You said what's the value I gave you for 1? No, you're dead. It's 1. I said multiply.
It was multiply it together, what do you get? We now know, ready? We now know that this expression, 6 times x times 5 times y, is an equivalent expression for 30xy. Let that kind of absorb, sink that in a little bit, get that into your head. Are you okay with that?
Yes.
So what you just did is you just did for the first time, officially, is combine like terms. You took all of your numbers, you can multiply those together, and then your variables can get multiplied together. Even if they're different, you can make that x times y and just call it xy. Okay? And on that note, we're up against the break, so we're going to take a break and we're going to build up next. Okay? Take a breather. Alright, so let me pick up where we left off last period, but I want to tell you again, when you create a new expression by combining like terms, you want to be able to test the new expression by substituting those numbers in, and if you get the numbers that are the same, then you know that you combined the terms correctly. You understand that concept? We'll always do that, we're always going to test the new expression by substituting in whatever numbers. Variables. Kind of what this is. We've already talked about it, but let's write it down. What did you notice between this answer and the answer from the previous page? They are ready. Identical. What book is that from? Identical. It's not Renaissance today. You should know this.
What year is it?
Well,
That's
it's back
okay.
way, but it's a
That
big grade.
wait, I know this.
Identical.
Smoking.
Joe Pesci was in it.
Oh wait, no, I know this. Oh, Tom Hardy. I was watching that. The golfing movie.
recaps everything that we just did. The example from the last previous page is called combining like terms. And then, see, here's where they start getting interesting. The word term, which I feel is because my beginning, is a term part of an expression that can be added or subtracted, blah, 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 what we've already covered in our notes. So when they give me this example, which we did in our warm-up, 3G, 4X, and 5 are called terms. Okay? Okay, so that's pretty much our day one. We're just practicing. Okay? We're going to go to the next page, and we'll do a couple together, and then I'll have you guys work a little bit through groups. And then maybe we'll finish off with market words and graphs. When you see the little smiley guy, always read what's in the box. They're little helpful hints. Collect all of the coefficients first. I'll show you what we mean by collect them. And then multiply those together. Then collect all of the variables and combine them where possible. So I'll show you what that means, but there's little helpful hints along the way in my work for you. So the example, 3 dot H, which means multiplication, can be combined together into one, by the way, 3 dot H, how many terms? 2. They can be combined together to make how many terms? 3H. 1 combined terms. 6 times A. Combine it, what do you get? Pull it out. 10. What's the coefficient? What's the variable? Let's do some more together. Here's what we mean by combine the coefficients, or combine the numbers. That's a number, that's a number. That's a variable, that's a variable. 3 times 7 is. What do you do with x times y? xy. Now look, let's call it coefficient variable. Then we're going to do a little mental check to see if this is equal. Coefficient is? Variables are? I want that correct. Let's do 2 and 1 again. Let's do a little mental check. 3 times 7. 21 times 2. Did you add? 42. 42 times 1. 42 times 9. How'd you get that? 42 stays 42. What's 21 times 2? Guys, what's 21 times 2? Times 1. As obvious, you're going to see that it works, but as they get more complicated, the mental checks or the substitution pin, it does help. Alright, what about number 3? Put it all together, combine all of your numbers, combine your variables, and make one term. Then I want to point something out to you. So, if you want to give it a try, I'll walk you through it. You ready? I'll walk you through it. 2 times 2 times 2.
4 and 8.
Good. Numbers are done. M times T.
Oh, and times 8 and 8.
Got it, done. Okay, give it a look. Okay. One thing I want to point out to you, I will not take off points for this, but if you remember to do it, that makes it even more of a mathematician. Is that when you list your variables, remember, multiplication is 81, or is 8 t the same as 8 tm?
Yeah.
Absolutely. But if you can remember, when you list your variables and you want to multiply it, you list them in alphabetical order. So you add the company before the state. Not that I'm going to take off points. When you do it, you list them in alphabetical order. Only for multiplication. When we get to day 2, when we talk about combining like terms with addition and subtraction, we're not going to necessarily worry about alphabetical order. But if you can do it with multiplication, that's great. What the heck? Let's do one more to go. you'll see. Oh, yeah. Coefficient is. Variables are. Alright, 4. And see if you can remember the alphabetical order tip as well. Okay, Ben, what do you got? I agree. Put it in alphabetical order. Hey. 30 headlines in. Let's do a quick check. Quick check. We'll make Z1, we'll make Y2, and we'll make M3. Let's just do it together. 5 times 1. Times 2. 10 times 2.
20.
20 times 3. 60 times 3. Put that over to the side. Let's see if the expression will work. 30 times, ready? 3, because M is 3. 90, right? 90 times 2. 180 times 1.
180.
It works. Test to do expression by plugging the numbers given for the variables. Alright, do 5, 6. Just go on to the next page. 5, 6, 7, 8, 9, 10, 11, and 12. You know what? Don't do them in groups. Do them on your own. Oh yeah, 4. Coefficient. Coefficient for number 4, guys. Shout it out, please. Variables are. Complete the rest of 5 and 6. Don't go on to advanced skip though. You can come for me for a check after you're done. Yeah. Hold on, somebody hit pause. The pause button on that. You hit pause. Major. Many of you got it right. And I just want to kind of go through also how I want to kind of organize stuff as you go, as you become, as you get more complicated. So if you do number 5, which you all got right, okay, but the way I like to teach it is that, okay, what are my numbers? I take care of coefficients first. What numbers do you say? 3 and 4. Now watch what we do. Every time you use it combining your term, I like to cross it out. So I have 3 and any other numbers. 4. Cross it out. What's 3 times 4? I like putting a little line through it because I can see when they start to get long, you won't know whether you counted it or whether you combined it or not yet. But if you cross it out, it's a little note and say, okay, I'm taking care of my numbers. Now, I want to start alphabetically. What comes first, A or B? How many are there? Now listen. Cross it out. Done. What's the next letter? The only letter that's A. Cross it out. Done. Okay? Again, it's simple, but it is helpful to help you keep track what's been taken care of and what hasn't. Coefficients 12. Okay, start with this. Take care of numbers first. What numbers do you say? 9, it was 3 times 9. I've already crossed it out. Out of the remaining letters, what comes first alphabetically? How many are there? Crossed out. Next, alphabetically. Crossed out, list it. Next, alphabetically. Crossed out, list it. And see, and look what I'm going to do. I like to put a little line there so it's easier. Okay? 27, BYZ. Okay, flip. Numbers first. Stop. 7, no others. Crossed out, list it. Start alphabetically. What's first in line? Followed by. And then when you guys hit number 8, some of you, not a lot, but some of you forgot back in lesson 1 is that repeated multiplication can be expressed as exponents. So just the same way as 5 times 5 times 5 is what as an exponent? Don't lose focus. 5 times 5 times 5 is what? 5 to the third. Therefore, g times g times g is what is an exponent? You want to write your combined terms with as few symbols and letters as possible. So I've got my 12, I cross it out. G times g is what is an exponent? Few. Coefficient's 12, but this is where I want to kind of vary my teaching a little bit. Only list the variable once. Because remember, if we say what's true, that a variable stands for a number, then really whatever g is going to be the g expressed as an exponent. We're not changing the value of g. Whatever we substitute in for g, it's going to be the same when you multiply it all 3 times. There's only one variable, g. Leave it as g. Don't list it 3 times. Okay? So let's look at these. Numbers first. What do you say? Mark, so. Cross them out, and that makes. Starting alphabetically. How many? Cross them out. 8 and 2. Next alphabetically. Fast. Only one of them. How many seats? 2. So if you've done it exactly the way you're supposed to do it, not only do we have to show those exponents, but look at the order in which it's being expressed. Try to remember that. And if you do it this way, like I'm showing you, it does become a lot easier. Numbers first in this big long expression. What do you got? Ugly expression. Multiply together, what do you get? Cross them out, make sure you cross them out. First letter you see alphabetically. How many? 2. Cross them out. How many Q's? Cross it out.
R.
How many?
3.
See? Start above it. Okay? So watch what I'm going to do. I'm only going to list the variables once. If you put an alphabetical order up here, then they'll all have to be in alphabetical order down here. But I don't care about the exponents just on the right. Is that right?
Yeah.
Okay? Numbers first. How many? Numbers are there.
3.
What's that? Oh, you're right. 8, 5. Okay. For number 4, how many numbers? 3. What are they?
4, 2.
Yeah.
4.
Alphabetically.
And
second. Good. Or in square.
easy.
This one got a star because we'll look through it first and I'll explain why it started. The combined term is I have 1x. I have x. The way that you're supposed to do it is put the x there because it is important, right? Listen, it's important. It is assumed that any variable by itself is a coefficient of what? Any variable that you say by itself really technically has a coefficient of 1. So even though I'm only putting an x here, I still have a coefficient. My coefficient is not 0. Because 0 times x will not be the same thing as 1 times x. Variable still stays x. Okay? Are you clear with that? Go back to your agenda, okay? Okay.
1, 2.
Two sets. answer. If you're regular. Okay, got it? Boys and girls, let me finish. Make sure you write this down exactly the way I have it listed, otherwise you put the wrong set. If you're regular math,